Hi guys, welcome to this revision summary video looking at the calculations involving masses from the key concepts in chemistry topic. The aim for this video is to look at all the key things that you need to revise to get yourself ready for the exam. If you want to go into more detail on any particular part, I've put a link in the top right hand corner to the playlist which goes into each section of the video in more detail, including practice questions and the model answers for them. So this is just an overview. If you want more detail, have a look at the playlist in the top right hand corner. The first thing we're going to do then is we're going to have a look at all the different calculations that you could come across from this part of the topic. So, the calculations you need to know. Relative formula mass. Empirical formula. So you need to be able to work out the ratios, you need to be able to work out the complex calculations, and you need to be able to work out the investigation. Conservation of mass. So what is conservation of mass, and how can you work out the maximum mass when you're given the masses of reactants or products? Moles and particles. How can you work out the moles, and from that how can you work out the particles using Avogadro's constant? Concentration. So how can you convert centimeters cubed into decimeters cubed, and how can you work out the concentration in grams per decimeter cubed? And then for the higher paper, limiting reactants and stoichiometry. We're going to start off with the easy one, which is relative formula mass. So nice and simply, the relative formula mass, all you have to do is add up the atomic masses. The atomic masses, remember, they are the big number on your periodic table. Now, the best way to go through this is to have a look at some practice examples. So I've got 4 questions here for you. Now, the first thing you'll notice is it always tells you the atomic masses in these questions. So you don't need to find them on your periodic table. The second thing, the key trigger you're looking for here is relative formula mass. The second you see that, add the atomic masses together. So if we have a go at carbon dioxide, CO2, you can see there's only one carbon here. Therefore, I have 1 times by my mass of carbon, which is 12. Oxygen, however, I've got 2 of them. You can see that from this little number down at the bottom. So whatever I do, I times by 2. So I've got 2 oxygens, which is 2 times by atomic mass of 16, which comes to 32. Then, as I said, add them together. So 12 plus 32 gives you 44, and that will get you your mark in the exam. Number 2, again, there's a lot of information here, but the key thing is work out the relative formula mass of calcium chloride. Calcium, we've got 1 of, so 1 times 40 is 40. Chlorine, I've got 2 of them, therefore 2 times 35.5, which is 71. Add those together, I get 111. Number 3, again, relative formula mass, it tells you in the question, there's your trigger, FeCl3. So Fe, you've got 1, and that's 1 times 56. And then chlorine, you've got 3, which is 3 times 35.5, which comes out to 106.5. So add both of those together, and you get 162.5. And then final one in this section, again, it tells you relative formula mass. The second you see that, add it together. You've got a more difficult one here of aluminium sulfate. Key thing, if you see a bracket, work out what's inside the bracket and then multiply it by outside. So if we use this as an example, aluminium, I've got 2 of. That's nothing to do with the bracket, so that's just 2 times 27, which is 54. Then let's have a look inside the bracket. So inside the bracket, I've got 1 sulfur. Therefore, I've got 1 times 32. I've got 4 oxygens, so 4 times 16, which comes to 64. So if I add them together, it gives me 96. But I've got that 3. So what I have to do is I have to take that 96 and I have to now multiply it by 3. So that comes to 288. So my mass of my sulfates in there is 288. Now I've got to add my aluminiums back on. So 54 plus 288 comes to 342 to get your mark. The next section we're going to have a look at is the empirical formula. Now, as I said, there are 3 sections to this. The first one we're going to focus on is how you can work out the ratios. So the definition for the empirical formula is the simplest ratio of atoms. So for example, if I have C6H12O6, what you need to do is you need to find the number, the biggest number that all three of those can divide into. And here you can divide all of them by 6. So if you do that, 6 divided by 6 is 1, 12 divided by 6 is 2, and 6 divided by 6 is 1. So my formula is CH2O. Another example, C3H9. Both of them can be divided by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So I have CH3. And then finally, both of them can be divided by 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. Therefore, I have Fe2O3. The key thing here is this will only be worth 1 mark. It becomes a lot more complicated, which is what we're going to move on to now. So, the complex calculations then. Let's have a look at a worked example. So this question here says an oxide of lead was analysed. 0.414 grams of lead was combined with 0.064 grams of oxygen. Calculate the empirical formula. So straight away you can see this is worth more marks, therefore you've got to do a calculation. So the first thing you need to do if you get a question that asks for the empirical formula is divide the mass by the atomic mass. So it tells you the mass in the question and the atomic mass it gives you underneath. So for lead it's 0.414 divided by 207, which comes out to 0.002. And for oxygen, you've got 0.064 divided by 16, which comes out to 0.004. That's going to get you 1 mark in the exam. The second one is to divide each of those numbers you've just worked out by the smallest number. That's going to give you your ratio of atoms. So my smallest number here is 0.002, so I divide both of those by that. 0.002 divided by 0.002 is 1. And 0.004 divided by 0.002 is 2. Therefore, I now need to put this back into my actual elements. I've got 1 Pb, I've got 2 oxygens, so my formula is PbO2. The third part of the empirical formula section is to have a look at how you can investigate the empirical formula. So you might get a question very similar to this, which says an experiment is carried out to determine the empirical formula of magnesium oxide by reacting magnesium with oxygen. And it then says describe an experiment to produce these results. So what you have to do then is list off a few steps of how you can do it. So the first thing, you want to measure the mass of your crucible and your lid. That's this thing up here. Once you've done that, you need to measure the mass of your magnesium and then add the magnesium to the crucible and heat strongly. So when you do that, the magnesium will start to react and it will turn into your magnesium oxide. During the reaction, lift the lid so it replenishes the oxygen, adds it back in, otherwise it will not finish the reaction and you won't get good enough results. So when it's fully reacted and turned into white powder, you need to remeasure the mass of the magnesium oxide crucible and lid, and then take away that mass that you measured out in step 1, so subtract the mass of the crucible and lid, and that tells you the mass of your magnesium oxide. So those are the 6 steps. The next section of the video is going to have a look at conservation of mass. So you need to be able to tell me what conservation of mass is, and then work out the maximum mass in calculations. If we start off with the definition then, nice and simply, the mass that you put into a reaction is always the mass that you get out. So the reactants equals the products. So for example, if I have hydrogen and react it with oxygen to make water, and I put 4 grams of hydrogen in and react it with 32 grams of oxygen, in total my mass of my reactants is 36 grams. Therefore my mass of my products must be 36 grams. So it doesn't matter what chemicals you're using, the mass in is the same as the mass out. However, you might need to be able to do a full-on calculation on this. They might only give you one of the values and say, you've got 4 grams of hydrogen, for example, how much water will you get? So for example, let's have a look at a question. We have the solvate process here, which is 2 NaCl plus CaCO3 goes to Na2CO3 plus CaCl2. And it says calculate the maximum mass of sodium carbonate that could be formed. So that is the thing that you want. So the first thing you do is work out the relative formula mass. Now, a really good habit to get into is the second you see relative atomic masses and chemicals in there, work out the relative formula mass. That's going to get you a mark. So let's start off with sodium carbonate. I've got 2 sodiums, that's 2 times 23, which is 46. 1 carbon, 1 times 12 is 12, and 3 oxygens, 3 times 16 is 48. Add that all together, I get 106. And then calcium carbonate, that's the thing that we have. So CaCO3, 1 calcium, 1 times 40, 1 carbon, 1 times 12, and 3 oxygens, 3 times 16, which is 48. So that gives me 100. So once we've got the relative formula mass, the next step is to divide the formula mass of the thing that you need, and the thing that we need is sodium carbonate, by the thing that we have, which is the 40 kilograms of calcium carbonate. So we take the relative formula mass of those, it's 106 divided by 100, which gives me 1.06. That's my ratio, so that gets me my second mark. And then all I have to do for my third step is take whatever that number is and times it by the mass in grams or kilograms or tons, which in this case is 40 kilograms. So 1.06 times by 40 gives me 42.4 kilograms for my third mark. The next calculation you need to be able to work out is concentration in grams per decimeter cubed. Now it doesn't matter if you see it grams decimeter minus 3 or grams divided by decimeter cubed, it's the same thing. All you have to do is to be able to manipulate this triangle, where mass is in grams, volume is in decimeter cubed, and concentration is grams per decimeter cubed. So if you want to work out the concentration, nice and simply, you need the mass and you divide it by the volume. However, sometimes they'll give you the question in centimetres cubed, so you've got to convert it into decimeters cubed first. And to do that, you divide by 1,000. So, for example, 22 grams of sodium chloride is dissolved into 650 centimetres cubed of water. What is the concentration in grams per decimeter cubed? So, marking point 1 is to convert the volume. We've got 650 centimetres cubed, we need to convert it, so we divide by 1,000, which gives me 0.65 decimeters cubed. And then once I've got that, all I need to do is mass divided by volume. My mass, it told me in the question, was 22, so 22 divided by 0.65, which comes out to 33.84615 grams per decimeter cubed. Now normally it's a good idea to round to 2 decimal places, but sometimes you might see something saying write your answer to 3 significant figures. So work out what 3 significant figures is, find your first value, go 3 figures beyond that, and then round up. So here I've got 33.8 grams per decimeter cubed to 3 significant figures. The next part is moles, mass, MR and particles. So how can you calculate moles, and with that how can you calculate the number of particles in a reaction? And it's all to do with one equation, which is moles, mass and MR. Mass is usually in grams, the MR is your relative formula mass, which we talked about earlier, and your moles, if you have 1 mole, you have 602,000,000,000,000,000,000. You have a lot of particles. In particular, 6.02 times 10 to the 23. That's Avogadro's constant. So what you need to be able to do is have a look at certain questions and work out how you do it. So let's look at the first one, which says calculate the number of moles of aluminium carbonate Al2CO3 3 in 117 grams. Now again, you've got atomic masses here, you can work out the relative formula mass. That's the easy marks in this question. So we have 2 aluminiums, 2 times 27, which comes to 54. If we look inside the bracket, I've got 1 carbon, so that's 12. I've got 3 oxygens, which is 3 times 16, which is 48. So inside the bracket, I have an atomic mass or formula mass of 60. But I've got 3 outside the bracket. So what I need to do is I need to take that 60, times it by 3, and that gives me 180. I can then add my aluminium to my carbonate, That gives me 234 overall for my relative formula mass. Now I need to work out my moles. As you can see from the triangle on the left, it's mass divided by relative formula mass. The mass it tells us in the question, which is 117 grams. The relative formula mass we have just worked out, which is 234. So 117 divided by 234 is 0.5 moles. Now, there could quite easily be an extra part to this question that says calculate the number of particles using the moles calculated in part 1. And as I said earlier, you take the number of moles and you times it by Avogadro's constant, which is 6.02 times 10 to the 23. And that comes out to 3.01 times 10 to the 23. If we have a look at another example, this time they might not even ask for the moles, they'll just turn around and say how many particles of sodium carbonate are present from 64 grams. Again, you've got atomic masses. Work out the formula mass. 2 sodiums, 2 times 23. 1 carbon, 12. 3 oxygens, 48. Add them all together, you get 106. 1 mark for that. Then the moles is mass divided by MR. Mass is 64 grams, tells you that in the question. Divide that by your MR, your formula mass we just worked out, that's 106. That comes to 0.603 moles. And then all that's left is to times that number by 6.02 times 10 to the 23. Put that into your calculator, and it comes out to 3.63 times 10 to the 23 particles. On to the penultimate calculation. This is definitely only in the higher paper, so if you're not doing higher, don't worry about this. Limiting reactants, which is the reactant that's used up first, the one that stops the reaction. So again, we have a look at a question. I've got 14 grams of hydrogen, H2, reacting with 20 grams of oxygen, O2, to produce water. Calculate the limiting reactant. So again, you've got your trigger word, limiting reactant. These are the steps you follow. Number 1, relative formula mass. Again, you've got atomic masses, so always work out your relative formula mass. I've got 2 H2, which means I've got 2 hydrogens, which got a mass of 2, but 2 lots of them. So my formula mass for hydrogen is 4. Oxygen, O2, I've just got 2 times 16, which gives me 32. So there's 1 mark for working that out. Your second mark, work out the moles. Mass divided by your formula mass. So my hydrogen, that's the mass in the question, 14 grams. You divide that by our formula mass of 4. That comes out to 3.5 moles. Oxygen, 20 grams, tells you in the question, divided by our 32, our formula mass, gives me 0.63. Nice and simply for your third mark, your limiting reactant is the smallest value, which in this case is oxygen. And then the final different calculation in this video is stoichiometry, where you use masses of reactants to balance equations. So again, if we have a look at an example, in a chemical reaction, 72 grams of magnesium was reacted with 48 grams of oxygen to produce 120 grams of magnesium oxide. Use the information to write the balanced equation. Now, I could balance that. I could work out that it's 2 mg plus O2 goes to 2 mgO. However, you'll see that there's no marks given for that because the question states you must show your working to gain the marks. So you can't just balance it. So we have to start by working out the moles again. And to do that, you've guessed it, the relative formula mass. So we work that out for each of our 3. Magnesium is just magnesium, so that is 24. Oxygen, you've got 2 lots of O2, so that's 32. And then magnesium oxide, 1 magnesium, 24, 1 oxygen, 16. Add them together, you get 40. So to work out the moles then, it's the mass divided by MR. So 72 divided by 24, 48 divided by 32, and 120 divided by 40, which gives me 3 moles of magnesium, 1.5 moles of oxygen, and 3 moles of magnesium oxide. Now you can't put those numbers into the equation because you can't have 1.5, so what we have to do is divide by the smallest again. So the smallest number is 1.5, 3 divided by 1.5, 1.5 divided by 1.5, and 3 divided by 1.5 gives me a ratio of 2 to 1 to 2. That's going to get you your third mark out of 4. And then finally, we add that to the equation. So I have 2mg plus 1O2, which we just don't write in, plus 2mgO. And that's my fourth mark if it was out of 4. So, let's do a quick summary of all the different techniques that you need to do. If you see relative formula mass, add the atomic masses together. That's the easy one. The empirical formula, your simple one, is find the smallest ratio, so the number that they can all be divided by, do it. And then for the calculations, divide the mass by the atomic mass, and then divide by the smallest number. That ratio is your formula. Conservation of mass, again, work out the relative formula mass, divide the thing that you want by the thing that you have, and then multiply by the mass in the question. To work out the moles, you divide the mass by the formula mass, and to work out the particles, you take those moles that you've just worked out and times that by Avogadro's constant, which is 6.02 times 10 to the 23. Concentration is mass divided by volume. Volume must be in decimeters cubed, so you have to divide whatever the centimeters cubed is by 1,000. And then both your limiting reactants and stoichiometry, the first steps are the same, so for both of them, work out the relative formula mass. Work out the moles, which is mass divided by your formula mass. And then for your limiting reactants, the smallest number is your limiting reactant. That's it. That's where you stop. But for your stoichiometry, you need to divide by the smallest number. And then that ratio is the numbers you put in front of your chemicals to balance it. Now hopefully what we've just been through has brought everything together and reminded you of the calculations you need to know. However, sometimes when you see them in front of you, it's very difficult to know what skill to use. So we're going to do one final part to this video, which is we're going to have a look at a set of different questions in a random order, and I'm going to work through with you of how you know what to do for each question. So my first question says, calculate the empirical formula of decane C10H22. Now straight away, it's worth 1 mark, so it's not a difficult calculation. It's just your ratio. So what can you divide both 10 and 22 by? There's only one number there, 2. So you divide both by 2, 10 divided by 2 is 5, 22 divided by 2 is 11. So my answer is C5H11 for 1 mark. Question 2. 15 grams of sodium chloride dissolves into 800 centimeters cubed of water. Calculate the concentration in grams per decimeter cubed. So we've got 15 grams and we have 800 centimeters cubed. So number 1, decimeters cubed. 800 divided by 1,000, that gives me 0.8 decimeters cubed. That's 1 mark. The second one, concentration is mass divided by volume. 15 grams divided by 0.8, and that gives me 18.75 grams per decimeter cubed. Question 3, calculate the relative formula mass. Hopefully all of you can do this by now. Add it up. I haven't put it in the question here, but the atomic masses of copper, 63.5, oxygen 16, hydrogen 1. I've got 1 lot of copper. In my hydroxide, I've got 1 oxygen, which is 16, 1 hydrogen, which is 1. So inside my bracket, I have 17. But I've got a little 2 outside, which means I have 2 times 17, which is 34. Add that to my copper, 63.5, and that gives me 97.5 for my 1 mark. Question 4. If 0.46 grams of sodium reacts with oxygen to form 0.62 grams of sodium oxide, what is the formula? So if you see what is the formula, that is empirical formula. So what you do is you put the masses in first, 0.46 grams of sodium. Oxygen, we don't know, but we do know sodium oxide is 0.62. So think conservation of mass, take my sodium away from that, 0.46, and that gives me 0.16. So my mass of oxygen is 0.16. I then divide that by my atomic masses, so 23 for sodium, 16 for oxygen, and that gives me a ratio of 0.2 to 0.1. I then divide by the smallest number, so divide both of those by 0.1. That gives me a ratio of 2 to 1, meaning my formula is Na2O. Question 5, work out the maximum mass of sodium chloride. Again, there's your keyword, maximum mass. So you've guessed it, the first thing you do is you work out the formula mass. Sodium carbonate, 2 sodiums, 2 times 23. 1 carbon, 12. 3 oxygens, 3 times 16. That gives me 106. Sodium chloride, I've got 1 sodium and 1 chlorine, but I've got 2 lots of the molecule. So it's 23 plus 35.5, and then double that gives me 117. I now divide the thing that I need by the thing that I have. I need the sodium chloride, 117. I have sodium carbonate, 106. So 117 divided by 106 is 1.1. And then finally, I times that number by my mass in grams. So 1.1 times 5.3 gives me 5.9 grams. Number 6. How many moles of lithium bromide are present in 3 grams of the solid? So again, moles is mass divided by mR. The second you see moles, that's how you work it out. The mass we've been given in the question, the mR formula mass, you've guessed it, work it out. 1 lithium, that's 1 times 7, and 1 bromine, that's 1 times 80. Add them together, that's 87 for 1 mark. Moles is then mass divided by mR, 3 divided by 87, which comes out to 0.034 to 2 significant figures. Question 7. How many particles of copper chloride? So the first thing we have to do here is work out the moles and then times it by our Avogadro's constant. Moles is mass divided by mR. We've got the mass. Again, work out the formula mass. 1 copper, 63.5. 2 chlorines, 2 times 35.5 is 71. Add them together. That gives me 134.5 for 1 mark. So therefore, 5 divided by 134.5 is 0.037 to 2 sig fig. And then all I do is take that number, times it by Avogadro's constant, which comes out to 2.24 times 10 to the 22. Number 8. 14 grams of ethene, C2H4, is reacted with 50 grams of oxygen, O2, to produce carbon dioxide and water. Calculate the limiting reactant in the above reaction. Once again, work out the formula mass. So the 2 things that we're talking about here are ethene and oxygen. So that's 2 times 12 plus 4 times 1. So that gives me 28 for my formula mass for ethene. And I've got 2 oxygens, so 2 times 16, but I've got 3 of them. So that's 32 times 3 is 96 for my formula mass for oxygen. Second step, work out the moles for each. Take the mass, 14 grams for ethene, divide it by the mR I've just worked out, which is 28. Oxygen, do the same, 50 divided by 96, which comes out to 0.5 and 0.52. The smallest one is my limiting reactant, which in this case is C2H4, ethene. And then final question, 2.52 grams of hydrogen, H2, is reacted with 20 grams of oxygen, O2, to produce 22.52 grams of water. Use the information to write the balanced equation. So remember, you can't get any marks just for balancing the equation, you have to do it through a calculation here. So start by writing the unbalanced equation. H2 plus O2 goes to H2O. Put the masses in that it tells us, and then work out the relative formula mass again. H2, 1 times 2 is 2. O2, 2 times 16 is 32. H2O, 2 times 1 plus 16 comes to 18. And then my moles is mass divided by mR, 2.52 divided by 2, 1.26. 20 divided by 32, 0.63. And then 22.52 divided by 18 is 1.26. All that's left is to divide by the smallest number, which is 0.63, which gives me a ratio of 2 to 1 to 2. Therefore, my balanced equation is 2H2 plus O2 goes to 2H2O. That's everything you need to know for this video. I've gone through quite a lot of information quite quickly. The link in the top right hand corner is everywhere you need to go if you want more practice on all of these with practice questions and model answers. So go up there if you're still stuck on any of these skills. Hopefully it's helped, and good luck in your exams. Hi guys, thanks for watching. If you enjoyed the video, please click on like down below. You can also subscribe to my channel, you can check out the latest video, and you can visit my website up above here. Bye now.